So now what we're going to do is we're going to switch over to looking more at nitrogen and the corn responses that we've seen here in South Dakota over the last 5 or 6 years. We're going to look at two different recommendation systems, the yield goal approach that we currently use in South Dakota and the MRTN, or the maximum return to nitrogen, which they use in the surrounding states in Minnesota, North Dakota, Iowa, and a lot of the other Midwest regions. So we'll kind of look at what that looks like in South Dakota and also look at how that compares in accuracy with the yield goal system that we currently use. As we start, we're going to first of all just look at some of the ranges in nitrogen rate requirements for South Dakota. So if we look here, we have on our y-axis, we have our economic optimal nitrogen rate, and then we have about 45 different research sites that we've been working on the last 4 or 5 years, and these are the different nitrogen rates that we've seen of them. So some of these that didn't require any nitrogen, and some of these are because of that soil health purpose. We have a couple sites in the central area that were drought and didn't require nitrogen. We have some that just had high residual soil nitrate. And we can see here we have quite a range of those nitrogen requirement sites. And you can see typically if we look at the mean area of this, it's about this 9,600 pounds of nitrogen per acre. If we look across the central and eastern region of the state, these are the typical nitrogen rates we're seeing a lot of times. So then we ask the question of what factors are influencing these nitrogen requirements. We're going to look at a few of the bigger factors that we talk about, such as tillage and region in the state. So when we look at this economic optimal nitrogen rate here on the y-axis, we have our conventional till and no-till. And here on these box plots, we'll see it's about roughly 75% of the data is within these box areas. The line is our mean and median here. And the small points are each individual trial. So you can see here, and the number above is the average. So on average, then across the central and eastern part of the state, we have 91 pounds per acre for conventional till, 100 pounds per acre for no-till. So really no statistical difference between these. There's a few pounds there, but nothing big. We do have a lot more sites in the conventional till area, a lot more on the eastern side. And we're still working on increasing the number of no-till sites that we have across the state. If we look here at previous crop, we see that overall we see a little bit lower nitrogen rate requirement on average and across the data for soybean if it's the previous crop versus a cereal crop such as wheat or corn on corn or wheat corn rotation. And that's typical. If we look here, we have 88 versus 115 pounds of nitrogen per acre. So we got 30-40 pound difference there, which is about what our 40 pound credit is between the soybean and the cereal crops. We did a comparison of two fields this last year, one with that previous soybean, one with that previous wheat, and it was about a 30-40 pound difference between those two fields, and they're within about 5 miles of each other in central South Dakota. So it goes to just kind of gives us more information that, if we're doing previous soybean, we can drop that nitrogen rate versus a previous cereal crop that does need to increase compared to that soybean. Something we probably expect is if you look in the eastern part of South Dakota versus the western part's typically lower yields, more limiting on the moisture. So as you would expect, the central, this is more central South Dakota, not necessarily west. You can see that there's a lower nitrogen requirement compared to east. And we'll see that in some other graphs that are coming up a little bit later in the presentation. So that's just kind of some general information that we've been looking at. So we have typically two different systems. Like I mentioned earlier, we have our yield goal system, which in South Dakota, we take that nitrogen fertilizer rate. Previously to now, we used the 1.2. We now use 1.0 to multiply that by our yield goal, our yield potential, subtract our soil test nitrogen, subtract our legume credit if we're using it. Sometimes we add 30 pounds if we're at over about to about 5 or 6 years. More than that, we kind of don't necessarily use it. And then we have our maximum return to nitrogen, which is a database of nitrogen response sites that look at yield versus nitrogen rate and the economics of where that one maximized, where we're not seeing an increase in profit. So to start out, we're going to look at the yield goal approach. And this is a little bit of a reminder. If you've seen presentations last year, I've showed a lot of this data, but this is the equation that we looked at: the yield goal times 1.2 minus soil test N minus legume credit. And then we're adding on that no-till debit if needed. So just an example, we take our yield goal 144, multiply it by 1.2, subtract soil test N, say 58 pounds of nitrogen. We are previous soybeans, so we subtract 40 pounds more. And say we just transitioned to no-till a couple years ago, so we had 30 pounds of N. We do the math, we get about 228 pounds of urea per acre, which would be our recommendation. So then the question is, how accurate are we? And these are just some updated graphs of what we've been looking at the last couple years to show you. So we did these 45 sites that you saw earlier, focused on central and eastern South Dakota. We have a couple out in west and Sturgis area. And as I mentioned earlier, a little bit more conventional sites versus no-till, but working on increasing that as we find farmers who are willing and able to let us use some of their fields. We have our previous crop. We have soybean at 35 of them, 10 sites where they were either wheat or corn. So if we look at this site here, we're going to look at pounds of nitrogen per acre, the requirement, and then we're going to look at the amount of actual nitrogen. So we have these sites over here, which are in central South Dakota, and we have these sites over here, which are more the eastern South Dakota. And really what we're changing between central and eastern South Dakota is just looking at the map. I kind of made the arbitrary decision of where we typically see more rainfall, and it's less likely to be limiting compared to where we're moving into central South Dakota, and we see less rainfall or more likely to be limiting on the rainfall. So here, this is SCSU recommendation as of using that 1.2, and then if we compare the blue line, the closer that blue line is to the red line is how close we are. We want it to be right on. If it's above it, that means we needed more than the recommendation. If it's below it, we needed less than the recommendation. So we look here, if you look across, we have some that the blue line is above it. For the most part, that blue line is below where that red line is, which means we typically tend to be either close or we tend to be over recommending nitrogen. So if we look at this a little bit differently, now we're going to look just the difference between the recommendation and the needed nitrogen. That's what's on the scale here. If we're above this 0 line, then we're going to be over recommending. If we're below it, we under recommend. So if we do that, it's kind of that same thing. We tend to be above that line, which means we're typically over recommending nitrogen. And the sites that we do tend to be under recommending nitrogen. The site's a very coarse textured soil and it was dry. These two sites were a little bit wet. This one in central, this was a drier year. So we kind of see those there. So then we want to know is, can we improve the current recommendation we have, or how does that look like? What can we do? So again, if we look at this equation, we look at the different areas we can improve. We have our no-till debit we can look at. We have our legume credit accuracy. We have our soil test N accuracy, and this coefficient right here. At first, we're going to focus on this coefficient. Is it correct, or can it be improved? So if we look at just that coefficient, and that's the pounds of nitrogen required to get a bushel of corn, is what that 1.22 is. And then this graph right here, we have that N coefficient for these sites. In central, you can see we range from 0.6 to 1.8. In the eastern part of the state, we range from 0.4 up to 1.7, but mostly around this 1.0 range from a lot of these sites. So we look at our current 1.2, you can see most of these sites are below that line down here and not above it. There's a few sites there are, but not very many. If we look at the average of the sites that we've done the last 5 years, that average is actually closer to 0.9 or 1, depending on what region of the state we're in. So it shows us that 1.2 is likely high, which we've seen. The recommendations tend to be overdoing it. So then if we compare those differences, if we look at the difference in accuracy of using 1.21, and let's just go lower and say 0.8, again, we're going to use this accuracy. So 0 is perfectly accurate, meaning our recommendation was exactly the same as our requirement. If we're above this line, it means that we overestimated. If we're below it, we underestimated. So if we have that 1.2 difference, we see that typically, again, we saw this already, that we're above it. If we move down to 1.0, what we want to do is we want to see, are we getting closer to this line? And we see all these ones that are over-recommending. That blue line is closer to the 0 than the red line. When we're under-recommending, it's getting farther away, which makes sense because you're lowering the amount of nitrogen you're applying. If you go down to 0.8, again, if you're under-recommending, you tend to start to go even more. If you're over-recommending, you mostly are getting closer to line. We do start to see some of these sites that are also popping down to this under-recommendation. So that shows that 0.8 might be a little low. We're going to look at this a little bit closer as well. So if we aggregate all those sites together and we look at the difference, again, we want something as close to this 0 line as possible. So see here, this 75% of the data, we want this box mostly around that 0 line. We see here we tend to be above it. We do have some that are sites that are below it because this kind of shows those outliers, or those 25% that are outside of here. If we go to this 1.0 right here, we tend to see that we tend to be, the mean and median is not quite central, but it's pretty close. If we go down to 0.8, it seems like we went a little too far because now we're at the top of the box and not really in the middle. You look at averages, you're plus 48, plus 13, and then you start to go about minus 22, which means we're doing 22 pounds of nitrogen per acre below the recommendation on average. We're plus 13, plus 48. So we can see this middle bar right here, this 1.0, might be a good middle ground between over-recommending on average and under-recommending on average. And this 1.2 isn't something that's been stable. It's changed throughout time. So if we kind of look through time, back of the recommendation for this, 1975 we're 1.45, 82 1.3, 91 1.2. And if we look at 2022, 2023, going into 24, we're around 0.9 or 1 is what the data is showing us. So the other question a lot of people ask when we look at yield goal approaches is, is there a relationship between yield and nitrogen requirements? Because a lot of places will show you that there's not. So what is it like in South Dakota? So in South Dakota, if we look at our economic optimal nitrogen rate, and we look at our yield goal approach, we kind of see as our yield goals or our yields are less, our nitrogen requirement is over here, and as we generally increase in those yield potentials, the nitrogen requirement goes up. This isn't an amazing relationship. Our R squared is 1011, 0.11, which is not great. 0.789 would be better, but there is a relationship there. And that's mostly because we look at these lower yield potentials in central and sometimes western South Dakota versus our higher yield potentials in eastern South Dakota. You kind of tend to see this. If we were to only cut this off about right here and look at this data right here, this is mostly eastern South Dakota, you wouldn't see a relationship. So if we have a good yield gradient, we see a decent relationship between yield and nitrogen requirement. However, we just look at central South Dakota over here, just look at eastern South Dakota over here, we don't really see a strong relationship between yield and optimal end rate. But if we look at a large spectrum, we do see that, which is I think where some people might be missing that, where a lot of states are just looking at high yielding areas, just looking at regions, you don't see it. But if you're looking at large variation in yield, we kind of do see that relationship. Not strong, but it is there. It shows us that there is something there. So then again, if we look at our current recommendation, that yield goal times 1.2 minus soil test stand minus legume credit plus no-till debit. If we look there, that coefficient, we're going to take that down from 1.2 to 1.0. It's going to drop that nitrogen requirement to 165, which overall, it's lower. It saves us money, and it shows that we can lessen it, which is, more money in the bank for us and less on fertilizer costs. And it shows us it's not decreasing our yield. It's actually, our yields are staying the same. So then the other question people ask about, so this is the yield goal approach. Here you don't see anything about economics as far as what the cost of fertilizer is, or what the profit is from selling the corn and things like that. We want to add that into it. Complicates the relationship some, but that's a lot of what the maximum return to nitrogen system does. So if we switch from our yield goal for maximum return to nitrogen system and look at how that does in predicting these nitrogen requirements, that's what we're going to look at next. So just kind of a graphic kind of explaining this maximum return to nitrogen. Here we're going to, instead of looking at yield, we're going to look at dollars per acre versus our nitrogen rate. And this is a field in Brookings, South Dakota in 2022. So if we look at, first of all, the cost of nitrogen, as our nitrogen rate increases, that cost, dollars per acre, is linear, just, more you put on, the more it costs, linear relationship. Next thing we're going to look at is this green line. This is our yield return to nitrogen. So this is the yield that we get from increasing nitrogen rates and what that increase in yield is. So as we imagine, as we start adding fertilizers, in this field especially, the line goes up, so we're getting more dollars per acre as we are adding more nitrogen fertilizer, and eventually that starts to kind of taper off and it goes flat at one point. So the yield isn't going up, so we're not getting a greater return dollars per acre as we add more nitrogen. And then if we take this yield return to nitrogen and we subtract our nitrogen costs, as our nitrogen cost increases too as we go up, we get a shape like this red line. So we get an increase in net return, so dollars per acre as we add more nitrogen, goes up, 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 and then eventually we're getting to the point right about here where we plateau in yield. And then since our nitrogen rate, as we put more fertilizer down, keeps going up, our net return or our profit starts going down. So if we look at where we get kind of that maximum rise point and start going down, we're right here, and that's about 75 pounds of nitrogen per acre. And if we go give us some leeway, let's go plus $1, minus $1. That's this right here, and that's at 70 pounds to 80 pounds of nitrogen per acre on this site. So what this maximum return to nitrogen system does is it takes a database of all the nitrogen rate response sites you can, it creates this graph, and then takes them, then kind of we put them together by region or different methods to see how that affects what this one would be. So this one is 75 would be the recommendation for it. And then you can also change, this is at a certain cost of corn, a certain cost of profit from corn, and cost of nitrogen. So as you can imagine, if the cost of nitrogen increases, this line would go from right here, it would increase in its slope and go up here. If profit from corn were to go up, corn prices were to go up, this is probably going to go up farther and keep going out before it plateaus somewhere later. If corn prices go down, it's going to plateau over here earlier. If nitrogen prices go down, this is going to go over further. You're going to be able to put more nitrogen because you're still increasing there. So there's some changes there. So if we look at that maximum return to nitrogen, how it affects by location, we take across 45 sites, regardless of where they are in the state. We're looking at about 97 pounds of nitrogen per acre, which we saw earlier in the presentation is our average nitrogen requirement. If we look at, how does tillage affect it, we look at our tilled sites versus our no-till sites. Our tilled sites are, 94, 97 pounds of nitrogen per acre, not anything significant, just a 3-pound difference in requirement there. And these are no-till sites in both central and eastern. They don't have enough to tease out central no-till versus that, and there's not a lot of tilled sites in central either. So we look at our rotation, corn, or corn, wheat, 98, corn, soybean, 95. This is a little surprising because when we look at just averages, this corn, or corn, wheat is more than the corn, soybean. So that doesn't necessarily show as much of a difference as I would expect as it does in the other system we looked at. If we look at location, we do see the difference we talked about earlier. It shows up in the MRTN system as well as the yield goal system. We have 102 versus 60, that 40 pounds extra. And this is that, or 40 pounds extra for eastern, and usually I would relate that to yield increase and less chance of precipitation being a limiting factor there. So if we kind of look at this, graphically, all of South Dakota, this is 2018 to 2021, 103 pounds of nitrogen we divide it by central and eastern, we have 81 versus 105. So we see that increase there. So if we want to look at, if we use that system to then predict 2022 nitrogen rate sites, again here we're looking at accuracy. We want that closest to 0 as possible. So these are central South Dakota sites. These are eastern South Dakota sites. We see here, if we look at just using the whole South Dakota MRTN, we still see generally we're overestimating in 2022, which is a little bit drier year. We have a couple of sites where we underestimated. This is a coarse texture soil. This is just your typical, it's a good loam soil. If we divide those sites by central and eastern and use those MRTNs to get accuracy, we see in central South Dakota, because we kind of lower that nitrogen requirement, we got closer. So it's showing that that general one for the whole state in central South Dakota is too high. The eastern South Dakota one is still pretty similar to the whole state average or whole state MRTN, so there's not a lot of difference there, but it's a little bit more accurate in some instances. And we can see, you know, we're plus or minus about 65 pounds per acre. If we look at the whole state, plus 65 in eastern, plus or minus 45, so a little more accurate for this system in central versus eastern South Dakota. That's with, you know, till and no-till sites all together, because we don't have enough sites to kind of tease them out yet. That's something I'd like to do as we get more sites in the future. So if we then add the 2022 data into there, and I'm working on adding the 2023 data in here, I just haven't had time this year. So if we add 2022 data into it, we go from 103 pounds to 97 pounds per acre for the whole state is the recommendation. We go from 81 to 60 in the central part, and we went 105 to 102. So not much change in the eastern part. Central part, we lowered it even more as far as nitrogen requirement. And that goes to show that, you know, 2022 is a little bit drier year in central part. This is probably why that drops that down. Which it'll shift as we keep getting more data. We'll kind of average out over time. So then again, if we look at this economic optimal nitrogen rate, we look at all of these sites, and then we say, okay, that 97 pounds is right here. And this is to say, you know, typical plus or minus 20 pounds nitrogen per acre. It would encompass these sites right here as far as being what I would call, you know, about as accurate as you can get, you know, a 40 pound per acre difference there. We have these sites where we would have under applied, and then we have all these sites over here, which is more abundant, where we would have over applied that nitrogen. So 14 of the sites within 20 pounds, 21 we'd be over fertilizing, and 10 we'd be under fertilizing. So it shows, you know, generally we'd still be over fertilizing more than we'd be under fertilizing. 14 sites, you know, we'd be within 20 pounds, which is pretty accurate. So then if we look at the accuracy, where we're looking at all of 2018 and 2022 data to do that, we have again here our central sites, and over here our eastern sites. We want to be close to the 0. We have our accuracy for using the MRTN across the whole state, and then again we tend to get a little bit more accurate in the central part. Eastern part stays pretty similar because the number is pretty similar. So we do kind of decrease that down to, you know, we're plus or minus 51, and then we hit plus or minus 46, which is better. So as we get more data, we're getting better. So this is a good graphic kind of comparing those two. Our red one is, you know, the accuracy. That this is our root mean square error, which is kind of the difference from being accurate. So the higher it is the farther from being perfectly accurate that we are. So we want it close to the 0 as possible. So using 2018 to 2021 data, you can see the number of, we can see kind of on average across all states we were 65, east 65, central 45. So if we add more data to it another year, we drop from 65 pounds per acre plus or minus down to 51, down to 46, pretty similar in central South Dakota, similar accuracy, but we're getting better in the eastern part, which is what we want. So as we're getting more data in the system, it does seem to be improving, and that's what we're looking for. So if we're comparing our yield goal system to our maximum return nitrogen, we're just looking at a few numbers here, kind of seeing how accurate they are. Again, we want these numbers as close to 0 as possible. So if we look at our yield goal at 1.0, we have that root mean square error, so that difference from being perfectly accurate or 0 difference between our recommendation and our actual. We're about plus or minus 55 pounds of N, so we're we're decently around this 0, which is good, which is what we want. We look at our MRTN for all of South Dakota, we're plus or minus 51, so a little bit better, pretty similar mark as far as, how much around this bar we are. We look at our MRTN for just using it in the eastern South Dakota, we're plus or minus 46, which is, it's a little bit better as far as what we're looking at here, as far as getting around it. This mean average bar is pretty central. This one's a little bit higher using the yield goal, but not a huge difference. We look at the MRTN for central South Dakota, it's a little bit higher, pretty typical to the yield goal system. Yield goal system works really well in drier areas, so that might be why we're a little bit better in central South Dakota, or similar to the yield goal system, central versus eastern's a little bit better with the MRTN. So I think that might be attributed to differences in rainfall, where yield goal system I think better accounts for how much residual nitrate is in that soil, because some years we're dry, we have a lot of residual nitrate and it needs to be accounted for, where the MRTN system doesn't inherently. It does it kind of through averages across time, but it doesn't take in the unique ones where we have different weather patterns as quickly as yield goal system does. So that's our system. We're looking at MRTN versus the yield goal system. So overall, we're not seeing a ton of differences. The next thing I want to do is